So here is another question on thermal expansion of materials. It is given that the design of a physical apparatus requires that there should be a constant difference in length at any temperature between the iron and copper cylinders which are used in this apparatus, and they are to be laid side by side. Okay, so there should be a constant difference of length between them. What should be the length of the cylinders at 0 degrees Celsius for the difference in length to be 10 centimeters at all temperatures? Then it is given the linear expansion coefficient alpha for iron is 1.1 into 10 to the power minus 5 per degree Celsius, and for copper it is 1.7 into 10 to the power minus 5 per degree Celsius. Okay, so here the situation is something like this. So this is the situation. Let's say we have this this first one. Let it be the iron cylinder, and this is the copper cylinder, which are laid side by side. This is at 0 degree Celsius, and let's say they have their initial lengths. This is, let's say, Li, and this is Lc, and this is Lc. Okay, so what it is saying, that what should be this initial length Li and Lc of the iron and copper cylinder, which is at 0 degree Celsius, such as when the temperature increases. So when the temperature will increase, both the iron and copper cylinders, they will undergo linear expansion as per their expansion coefficients, but the difference of length between these two cylinders, it will remain intact. It will stay the same what it is. Okay, and this difference of length is how much? 10 centimeters. The difference of length is 10 centimeters. Okay, between the two cylinders. Okay, so let us try to solve it. Let us say the initial length at 0 degrees Celsius for the iron cylinder, the initial length is of iron cylinder, that is equal to Li, and that of the copper cylinder is, let's say, Lc. Let's say there is an increase in temperature of delta T, okay, from 0 degrees Celsius. So there will be corresponding increase in lengths of iron and copper cylinders. So let's say the increase in length of the iron cylinder is delta Li, which is equal to the linear expansion coefficient alpha, the initial length Li at 0 degrees Celsius, and the rise in temperature. Similarly, for copper, it is alpha C, the linear thermal expansion coefficient, the initial length of the copper cylinder, and the increase in temperature delta T. Now, as per the condition in the question, the difference in lengths between the initial length of iron and copper cylinder, that is 10 centimeter, and also at any temperature, even after thermal expansion of both the cylinders, this difference should remain the same. That is the main condition. So let's say the increased lengths after an increase in temperature of delta T, let that be Li dash, and for copper let's say it is Lc dash, the increased length. So this difference should remain the same, that is also 10 centimeter. So here Li dash, the increased length in iron cylinder, is equal to the initial length Li plus this expanded length, linearly expanded length delta Li, which is equal to Li plus alpha Li delta T. Similarly, the increased length of copper cylinder is equal to the initial length of the copper cylinder plus increase in length, which is equal to Lc plus alpha Lc delta T. So let's name them. Let's say this is equation 1, this is equation 2, this is equation 3, and this is equation 4. So if we put equation 3 and 4 in equation 2, it means we have, let me use a different ink, Li plus alpha Li delta T minus Lc plus alpha Lc delta T, that is equal to 10 centimeters. So let's just keep it 10. So when we simplify it, it becomes Li minus Lc plus alpha Li delta T minus alpha, this is alpha I, okay, alpha I, this is alpha C, okay, alpha I Li delta T and alpha C Lc delta T, that is equal to 10. Okay, just we have rearranged the expression. That implies here Li minus Lc, the initial difference of lengths, that is also equal to 10. The initial difference in lengths of the two cylinders at 0 degree Celsius, that is also 10, plus alpha I Li delta T minus alpha C Lc delta T, that is equal to 10. So when 10 goes to the RHS, that implies alpha I Li delta T minus alpha C Lc delta T, that is equal to 10 minus 10, it becomes 0, or that implies alpha I Li delta T is equal to alpha C Lc delta T gets cancelled, that implies alpha I by alpha C is equal to Lc by Li. So this is one important relationship. This is derived from the same, but it's easy to keep them in boxes so that we highlight them. So let's name it 5 and this 6. So the ratio of the linear expansion coefficients of iron and copper is equal to the ratio of the length of the copper cylinder and iron cylinder. That implies Lc by Li is equal to alpha I 1.1 into 10 to the power minus 5 by alpha c, which is equal to 1.7 into 10 to the power minus 5. It is given in the question, the linear expansion coefficients of iron and copper. So it is equal to 11 by 17. Okay, 11 by 17. So that implies Li is equal to 17 by 11 Lc. This is another important equation. This, so let's call it equation 7. Now if I substitute this Li is equal to 17 by 11 Lc in the first equation that we got, that is the difference in lengths, Li minus Lc, the initial lengths at 0 degrees Celsius, this is equal to 10. Here if I substitute this value of Li in terms of Lc, it will be 17 by 11 Lc minus Lc is equal to 10. Okay, that implies that implies 6 by 11 Lc is equal to 10. That implies Lc is equal to 110 by 6, which is equal to, it's coming around 18.33 centimeters. The length of the copper cylinder at 0 degrees Celsius, the initial length, that is equal to 18.33 centimeters. This is the first. Then the difference in length, Li minus Lc is equal to 10. Okay, so Li is equal to Lc plus 10. So 18.33 plus 10 centimeters, which is equal to 28.33 centimeters. So length of the iron cylinder at 0 degrees Celsius is equal to 28.33. Okay, so both the lengths of the iron and copper cylinder, the initial lengths at 0 degrees Celsius, we have calculated. Okay, so the question was, it was straightforward, just simple, but there were a lot of, calculations involved, a lot of simplifications, a lot of equations, substitutions. So that can make it a bit complicated, a bit lengthy, and because of the lot of equations that are involved, a lot of simplifications which are there, sometimes it can lead to mathematical calculation errors. Okay, otherwise it was a very simple and straightforward question, but it involved a lot of steps and equations. Okay, so this is the thing.